Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last video, we looked at how we could use some recursive functions to do some calculations. We calculated factorials. We also did a calculation of summing up numbers so that we could take an average. Now, what I want to talk about in this video is to take that a little bit further. So, if we go and we look at our file for averaging, we had this function called read and sum, and it was supposed to read in integers and give us back the sum of them. What if instead of taking just either a simple sum, so what if instead of a sum I want a product? Okay, so I want to have the product of all the numbers that are input. Well, one way to do that would be to copy 8 lines, paste them, change this from read and sum to read and product, and instead of having a plus there, we have a times. The other thing we need to change is this here, because when you're adding up a bunch of numbers, at the end you want to add 0, kind of as your base case, because adding 0 is the additive identity. When you add it to something, it doesn't change anything. Now we're doing multiplication. What happens if we multiply by 0? Well, then everything becomes 0. So for multiplication, we need to change this to 1, because 1 is the multiplicative identity. And now we could do something like, well, if I were to call this with a product, let's actually say 2yy and p product Now, of course, for a product, you don't just want to take the average, you actually want to take a root. I'm now doing a geometric mean. And with the geometric mean, I don't need to convert this to a double. Okay. So it'll read a bunch of numbers, take their sum, give you the average. It'll read another set of numbers, take their product, and give you the geometric mean of those. And if we were to run this, I'll just say 3 numbers. One, 2, 3, with an average of 2. 1, 2, 3, with a geometric mean of 1.81712, etc. Okay, so let's go back and let's look at these functions. And I've said before, copying and pasting is generally a bad thing. If you can, you'd like to avoid it. Now, in this case, we did change some things. Changing the name really wasn't that significant. That wasn't required. If I had deleted this one, I wouldn't need to change the name. There were really 2 things I had to change here. One was I had to change the plus to a times, and the other was I had to change the 0 to a 1. Okay. So really, this function and this function are exactly the same, except that they return a different value on the base case, and they combine things in a different way. And that's the only difference between them. That's the only real change of substance that I made when I did this cut and paste. And that is inefficient. Okay, if I were to find that I had other things, so maybe I wanted to do a root mean square, so I want to take the sum of the squares instead. Or maybe I wanted to combine these instead of having a product or a sum, I wanted to take the min or the max, something like that. Okay. Well, you can imagine all types of things that we might want to do in order to combine these numbers. And the problem is that completely copying and pasting and redoing the code is inefficient. So what I'm going to show you here, and in some ways this is a bit more advanced technique, and your instructor might not be ready for you to deal with this. But we've learned all of the pieces for this. It's just putting them together. I want to throw in one more piece to this. I want to write a recursive function like this, but I'm going to use the piece of a function literal, or pass in a function. So this is a value, the base case, the 0 or the 1. So let's do, actually let's 8YYP, read, and how about combine? So we're going to read in things, but I want to pass in a little bit of additional information. I want to pass in a base case, which is the int, since this whole thing returns an int. This is the value that gets returned when you get to the bottom. And so I'm going to change from the 1 or the 0 in the sum to this variable base. And then the next thing that I want to pass in is a function to combine things. I'll call it combine func. Now, what should this function do? Well, it's supposed to take two ints. Down here, one would be the grade that was read in, and the other one would be the result of the recursive call, which is also an int. And it's supposed to return to us something the whole thing can return, which is an int. So the signature for this is int rocket int. Okay, so that's the type of function that I need to pass in. And where do I use that in the function? Well, it goes in place of the add or the multiply. So I'm going to put inside of here combine func. So the idea is I can pass in whatever base I wanted. If I were taking the sum, I could pass in a 0. If I were doing a product, I'd pass in a 1. If I were taking the min or the max, I might pass in int.max value or int.min value, whatever the opposite is, the thing that couldn't possibly be the min or the max. And then when it comes down time to combine them, instead of using an operator like the plus or the minus, I am going to call this combine func, whatever that function is, and apply it to the two arguments. So let's see how this can be used. I'm actually going to come down here and comment out the main part of the script so that you can see this in the REPL. And then we'll go back and I will change the other two things that I did so that they do the same thing as read sum and read product, but they do it by using this new version. So I load in all my functions. Let's see if we type them correctly. Yes. So how do we call, so just to make sure this works, read and sum 3, 1, 2, 3 gives us back 6 because that's the sum of those. And we could do the same type of thing for the read and product. Read and combine. Well, I need how many things to read? I'm going to go with 3 because I want something that's fairly short. The base, well, if I'm doing a sum, I'll go with 0. And then a function. Now, I'll write this the first time using the function syntax that we talked about the first time. I'm going to say I have a function, it takes two arguments. I'm calling them x and y here. And it gives back x plus y. Let's put some spaces in there. Maybe that'll help you read what's going on. And now if I type in 1, 2, 3, oh, hey, look at that. No? We got an extra one. Read and combine. 0. Oh, I see why. It's still calling read and product. So when I call this with n minus 1, I'm going to use the same base and the same combine func. Okay. Let's load it back in. And let's run it. 1, 2, 3 with a sum of 6. Otherwise, I got 1 plus, and then it went to the product, and so it said 2 times 3, and that's why I got 7. If I wanted this to do multiplication, I would change this to that and change the base to 1. 1, 2, 3, which also happens to have a product of 6. What happens if I do multiplication with a base of 0? 1, 2, 3. Well, 0 times anything is 0. So that's what I get. Yeah, so this one function, the read and combine, is far more flexible. This is, by Scala standards, a little bit verbose, though. One thing that you'll note about this is that I didn't say x is an int, y is an int. When I introduced function literals, I showed you these, but I said that in most cases when you use it, you don't have to include that. And you might wonder, well, why not? Well, because Scala can look at this x and y, but this here says it's going to take a function that is int and gives you back int. It knows those two arguments are an int because we told it right here. So if this is going to work in there, it has to be 2 ints. Because this is something that you do fairly commonly in Scala, it turns out there is an even shorter syntax for this that uses underscores. Now, you can only use this in certain situations, but you can think of the underscore as saying some variable. Okay. So instead of saying I have an x and a y and I want to give back x plus y up here, I can say something plus something. Okay. 1, 2, 3, and it works. The limits on when you can use this short syntax. For example, if I wanted to say the function of something squared, I can't use this because it sees the first underscore as the first argument and it sees the second underscore as the second argument. If you only have one underscore, you're dealing with a function of one argument. If you have 2, it's 2. If you have 3, it's 3, so on. So the arguments have to appear exactly once and in order for you to use the shortcut underline syntax. But as you can see here, it made this really nice and short. 4, 5, or 3, 4, 5 gives us 60. Okay, so you can pass in a little function here, and this short syntax makes it possible to get a lot more power. So now I don't have to write new versions for everything that I want to do. This won't give me the ability to combine square. Actually, I guess it will. Let's try that. So I had said something about doing the sum of the squares. So just to make sure, so the sum of the squares for 1, 2, 3 should be 1 plus 4 plus 9. We expect 14. Now it turns out that sum of the squares is something I can't do with this short notation. I have to go back up and pull in the long notation because I want x times x. I want to take the first argument and square it and then add in the second argument. And at the base case, that second argument here is going to be the base, which is 0, since it doesn't add anything. So if I hit enter, 1, 2, 3, I get 14. It did the 1 plus the 4 plus the 9. And now I could just combine that with a call to math.squareroot, and I could get the standard deviation. So this version right here, by passing in a function, is fundamentally significantly more powerful than what we had before. And now this is an idea that will probably take a while for you to wrap your head around, but you can play with doing different things using something like this read and combine and trying to see what different types of functionality you can get. How would you do min? How would you do max to find the largest number or the smallest number? Anyway, that's it for this video. I'll see you again soon.